Okay, this is the fixed video that finishes off lesson 4.1. There was just a little bit left on this first problem from example 5, and basically that was just that I want to rewrite this a little bit. So, if I have the 3 halves and I have the 1 halves and they're the denominators, I know that I can flip them and change the way my problem looks a little bit. So the first thing I'm going to do is clear some space up here. And then I'm going to write the 2/3 x to the 3 halves plus 2 x to the 1 half, because 2 is the reciprocal of 1 half, and then of course plus c. And so that's my actual final cleaned up solution. Alright, and then I had example 6, which, two things, has trigonometry in it, and also you have to really rewrite this. So first of all, to rewrite it, I'm going to write sine over cosine squared x as sine x over cosine x times cosine x dx. When I do that, you might be able to see right off the bat that I can do some grouping. Sine x over cosine x is tangent x. And that leaves me with a 1 over cosine x, which is secant x dx. Okay, so that makes a totally different problem. Now when I want to integrate this, I just have to think to myself, where does tangent secant come from? Well, actually we usually see it in the reversed form, but secant tangent is the derivative of secant. So if we integrate secant tangent, it integrates back into secant x plus c. Okay, probably the most important example that was left off of the last video is example 7, where we're going to talk about particular solutions, because this is something that's going to come up especially in free response questions. Okay, so FRQ alert right here. If you're given a problem like this where they give you a derivative, you can know it's a derivative because it has a prime. So f prime of x is 1 over x squared, and they give us an initial condition. That's very important. Then we're going to find the particular solution. To do this, we're just going to start off by integrating our differential equation. 1 over x squared is our differential equation. Just rewriting it. So the integral of 1 over x squared is the same thing as the integral of x to the negative 2. And to integrate that, I get x to the negative 1 over negative 1 plus c. Now what I should say about this is that this is really equal to f of x equal to f of x. Okay, so my f of x is now negative 1 over x plus c. Went ahead and simplified this just a little bit. Okay, so how that helps me is that I was given an initial condition, f of 1 equals 0. That means this is the x value and this is the y value. And so where f of x is, I'm going to put 0. And where x is, I'm going to put 1. And that's actually going to tell me what my c equals. So if 0 equals negative 1 plus c, then c is going to be equal to positive 1. So that gives me a particular solution, because when I go back to write this equation, I'm going to say, I'm not sure where I'm going to put this, but I'm going to go back and say, let's go right here. There's a little bit of space here. Okay, so now I know f of x is negative 1 over x plus c, but we know our c is 1. So now I have a particular solution. The general solution had the c. The particular solution has been solved to find out what that c is equal to. Okay, and then here are the here's the assignment that went with this, and if you haven't already done it, you can do it now.